Good morning, students of third prep. Manor Salem Language School will present the science for the third prep. Today we'll talk about the second term of third prep, Unit 2, which talks about the electric energy and the radioactivity. Let's start with the first lesson, which talks about the physical properties of the electric current. Before we talk about an electric circuit, let's say why we need electric current in our life. We can't imagine our life without electric current because we use electricity in our daily life, as we use it to light our houses, our factories, our streets. It's also used to operate many machines like radio, television, washing machine, iron, electric heater, and so on. So electricity is used in many fields in our daily life, and it's also one of the cleanest sources of energy that doesn't pollute the environment. How can we form an electric circuit? The electric circuit, or the simple electric circuit, can be formed by four parts. First, lamp to operate it, and electric key to open or close the circuit, and connecting wires which are made of copper to connect the electric current from a part to another part through the circuit, and finally the battery, the main source of electricity in our circuit. If we form a simple electric circuit that was shown, we can move the electric current from the battery to the lamp to work it, and we can use the key to open or to close the circuit as we want. And this moving electric current through the wire, where it comes from, we thought that the atom consists of or contains nucleus, which is positively charged because it contains positive electrons, positive protons, and surrounded by energy levels where electrons, which are negatively charged, are moving in it, and there is attraction force between the nucleus, which is positively charged, and between the moving electrons that produce this electric current. And this generating electric current can be said that it's the flow of the electric charges or the electrons through the conductor or through the wire. And this moving electric current has many properties, or has three physical properties, which are: number one, the current intensity. And this current intensity can be measured by counting the amount of electric charges or electrons that's moving through this wire or through a cross section of this wire in 1 second. And we symbolize the current intensity by symbol I, and can calculate it by dividing the quantity of electric charges dividing the time. And we can give the quantity of electric charges symbol Q and the time T, and we can say that I, the current intensity, equal Q over T, quantity of charges dividing the time. How can we calculate electric current intensity that's passing through a certain circuit? By connecting a device called ammeter, and this ammeter is connected in series, as we connect the negative part or the negative line of the ammeter with with the negative of the circuit and the positive with the positive as a part of the circuit to count the current intensity of this circuit. The second property of the electric current is the electric potential, and this electric potential is a state that shows the transfer of the amount of electricity from a point to another point, and we get this potential difference symbol V, and it's equal the work done by the electric current to transfer quantity of charges from a point to another point, and its unit is called volt. To measure the potential difference in a certain circuit, we connect a device called voltmeter, which is connected in parallel with the circuit to measure the potential difference of the circuit. If we want to calculate the potential difference of the battery, we call it electromotive force or EMF. It's the potential difference, but only at the two poles of the battery, and it also measured in volt. The third property of the electric current is the electric resistance. Resistance means opposition. When the electric current is moving through the electric wire, it opposes or faces by the electric current, and this resistance has two types: type called constant resistance and type called variable resistance or rheostat, and it's used inside the circuit to change the resistance of the circuit and as well the electric current intensity and potential difference will change. A scientist called Ohm made this circuit, which consists of a battery, a key, a meter, voltmeter, and constant and variable resistance to find the relation between the potential difference and the current intensity, and he started to change the rheostat time after time for many times, and he found that when he changes the resistance, the potential difference will change, or the reading of the voltmeter, which can calculate the potential difference, will give a different value, and also the ammeter, which can calculate the current intensity, will give a different value, and this value changes by changing the resistance, and in every time he found that there is a direct relation between the potential difference and the current intensity, and in every time he found that when dividing the potential difference by or divide the current intensity, it gives a constant value in every time, and this constant value is the resistance of the material he used in this circuit. So he deduced Ohm's law, which is equal with the resistance equal potential difference divide the current intensity. Let's move to lesson 2, which talking about the electric circuit, electric current and electric cells. Sources of electric current. How can we generate electric current? By two ways. The first way is the electrochemical cells, and inside these cells we will change the chemical energy into electric energy like in batteries. The second way is electric generators. It's a devices that it changes the mechanical energy inside it into electric energy. So we have two ways to produce electricity or electric energy or electric current. And this electric current that produces by different ways has two types. The first type is called the direct current, and the direct current is produced by electrochemical cells or dry cells or the batteries, and it has certain properties as it has a constant intensity and cannot be transferred to long distances. It can only transfer to short distance and cannot be converted into the second type, which is called alternating current, and it's used to operate appliances. The second type of electric current is called alternating current, and this alternating current has a variable intensity and has two directions, and is generated by the electric generators, and it can change into direct current and can transfer to far distances through wires, and it's used in lighting houses, lighting streets, operating electric appliances. It's used in many ways. How can we connect a number of electric cells or dry cells together? We have two ways of connection. The first way is called series connection. It means we can form a series from all the cells, starting with the first and then connecting it to the second, to the third, and so on, and we take the end of the last one and the starting one and connect the whole circuit with that. In this connection, if we want to calculate the EMF, the total electromotive force, we will sum all the electromotive force of all the used cells, so we get great EMF. In the second way of connection, it calls parallel connection, and we connect the positive part of this cells together in one wire and the negative part of this cells in one wire, and it takes the positive and the negative to connect the whole cell. And in this way of connection, the electromotive force of the whole cells equals the electromotive force of one cell only, as all the cells is acting as one cell in this connection. Let's move to lesson 3, which talking about the radioactivity and nuclear energy. What's the meaning? What is the nuclear force? We knew that the nucleus of the atom contains positive protons, a large number of positive protons, and we knew also that if we have two objects carrying the same charge, they repel each other. So we have a large number of protons in a small, very small area, which is called the nucleus. The forces that bind the nucleus component together and overcome this repulsion force between these positive protons is called the nuclear force. And we have also a radioactivity phenomenon. What is the radioactive elements? We knew that all elements are searching for stability, but in some nuclei of some atoms, the number of neutrons inside this nuclei is more than the required number for the stability. So the atom contains a large number of neutrons, and it's called radioactive element. And these elements, which have a large number of neutrons, make a radioactivity phenomenon. What is the radioactivity phenomenon? It means that the nucleus of this atom, from the radioactive element are not stable, so it has a spontaneous decay. It decayed. How? By making radiations like cesium, like radium, like rubidium, like uranium, like zirconium. This is called radioactive elements. What are the peaceful uses of the nuclear energy? It's used in medical field to diagnose or treat diseases like cancer. It's used also in agriculture fields, like to eliminate pests and to improve some plant races. It's also used in industrial field to convert the sand into silicon sheets, which is used in manufacturing of computer processes or programmed electric circuit or electric appliances, or to discover the defects in manufactured products. It's used also in electricity generation field, how as the nuclear energy used to heat water that produces steam, and this steam is used to generate electricity by using turbines. It's used also in a space exploration field, as the radioactive materials are used as a nuclear fuel for the rockets to fly in the space. It's used also in drilling field for drilling of petroleum and underground water. What is the effects of radiation? Radiation means increasing the amount of radiation in radiation pollution means increasing the amount of radiation in the environment, and it has many effects. Number one, a physical effect, as they can change it make changes that appear on the living being or living organisms as a result of exposure to radiation, like skin cancer. It also has a genetic effect, as they can change in the sex hormones composition that result in abnormal birth. It also has cellular effects, as they can change in the cell composition, which leads to destroy the whole cells. As if the chemical composition of hemoglobin changes, it becomes incapable to carry oxygen. How to protect ourselves from radiation pollution? Number one, we have not to be exposed to maximum safe dose of nuclear radiation, which is approximately 5 Rem 1 day. Number two, the workers with radioactive elements in labs or in hospitals should wear radiation protective gloves, clothes and masks. Number three, we have to follow the precautions while dealing with radioactive wastes, as this waste should be away from the underground water path, so this water will not be polluted. Number two, the area chosen for storing this radioactive wastes should be steady. One, not be exposed to earthquakes, not to be exposed for volcanoes, and away from animals and that live in caves. Number four, the nuclear wastes or of weak or medium radiation should be surrounded by cement layer, because it prevents the radiations coming out from it before placed it deep in the ground. And the wastes of strong radiation should be cool and using water and then deeply buried in the ground. Finally, we should works on the laws for nuclear stations to cool the hot water before throwing it in the seas. And this is the end of lesson 2, lesson 3 unit 2.